Assalamualaikum guys, welcome to my YouTube channel Analytical Chemistry. I hope that you all are doing good and well. So guys, we are here with another new and interesting topic of the analytical chemistry. And before starting my video on the important topic of the fluorescence, molecular fluorescence spectroscopy, I have to discuss in this video the most important definitions regarding to the molecular fluorescence, luminescence and fluorescence types and so many other things. So let's start our video. First of all, what is luminescence? It is defined as the emission of the photons from electronically excited state. The term luminescence comes from the Latin lumen means light, first introduced by the luminescence by German physicist and science historian Alfred Weidmann in 1888. It is defined as a spontaneous emission of the radiations from an electronically excited species or from a vibrationally excited species, not in thermal equilibrium with its surrounding. And it is divided into two types, including single state and triplet state. Now we are going to see that what is singlet and the triplet state. In a singlet excited state, an electron in the higher energy orbital has the opposite spin orientation as the second electron in the lower orbital. These two electrons are said to be the paired. Return to the ground state from an excited singlet state does not require an electron to change its spin orientation. Got it? Another one is the triplet excited state, and in these electrons are unpaired. That is, their spins have same orientation, and a change in spin orientation is needed for a triplet state to return to the singlet ground state, and for example in case of free radicals. Now the ground state includes two electrons per orbitals. Electrons have opposite spin and are paired. Types of luminescence are two types: photoluminescence and chemiluminescence. First one is the photoluminescence. The molecules are excited by the interaction with photons of radiation, and it is further of two types, including fluorescence and phosphorescence. What is fluorescence? When a beam of light is incident on a certain substances, they emit visible light or radiation. This is known as the fluorescence, and fluorescence start immediately after the absorption of light and stop as soon as the incident light is cut off. The substances showing this phenomenon are known as fluorescent substances, and fluorescent substances are of further two types. First one is the prompt fluorescence, second one is the delayed fluorescence. Prompt fluorescence, S1 into S0 plus HV, the release of electromagnetic energy is emitted or from the singlet state. And delayed fluorescence include S0 into S1 into T1 into S1 and further into S0 plus HV. This results from two intersystem crossings, first from the singlet to the triplet, then from the triplet to the singlet. Also you can see the picture here. First one is the fluorescence, second one is the phosphorescence, third one is the delayed fluorescence. Now what are the phosphorescence? When the light radiation is incident on a certain substances, they emit light continuously even after the incident light is cut off. This type of delayed fluorescence is called phosphorescence, and substances showing phosphorescence are called phosphorescent substances. Its types are chemiluminescence. The excitation energy is obtained from the chemical energy of the reaction, that is the oxidation. And other types of luminescence are the radioluminescence. Radioluminescence include the excitation energies obtained from the ionization radiation, including X-ray, alpha, beta and gamma rays. Triboluminescence are release of energy when a certain crystals are broken, that is sugar crystals. Cathodoluminescence including the release of energy produced by the exposure to the cathode rays. Further types of fluorescence include based upon the emitted radiation, which are Stokes fluorescence, anti-Stokes fluorescence and resonance fluorescence. Stokes fluorescence include emitted radiation wavelength is longer than the absorbed radiation wavelength, for example conventional fluorometry. Anti-Stokes fluorescence include the emitted radiation wavelength is shorter than the absorbed radiation, for example, thermal fluorometry. And the resonance fluorescence included the emitted radiation wavelength is equal to the absorbed radiation, for example, mercury vapors at 254 nanometer. Second one is the based upon the phenomena. There are also three types including sensitized fluorescence, direct line fluorescence, stepwise fluorescence. Sensitized fluorescence include when the elements such as thallium, zinc, cadmium are added to the mercury vapor. It is sensitized and produces the fluorescence. And the direct line fluorescence included after the emission of the radiation, the molecules remain in the metastable state and finally come to the ground state. And stepwise fluorescence included the part of energy is lost by a vibrational transition before the emission and the fluorescent radiation. So these are the basic types of the fluorescence. I hope that you completely understand the basic difference between the luminescence and the fluorescence, their types, and so many other things. So if you completely understand, go and like my video, subscribe my channel, and wait for my another topic, which is the molecular fluorescence spectrometry, which we are going to discuss, we are going to discuss in our another video, next video. So Allah Hafiz.